Just going to give a little bit of a chat about the different variable types we have. You saw me use a variable called a in a program, but there are other types of variables, and then we'll look at a little program which we'll use for actually trying to tune up a servo axis to make it function properly. The a that I showed you in the little example earlier is known as a local program variable. So that gets invented when you type it in the program. Okay, and you can name it anything you want. It can be any size of name between 1 and 32 characters. You can actually make it even longer than 32 characters if you want to make a really descriptive name, but actually anything after character number 32 will be ignored as far as differentiating that from another variable name. So if you make two variables, one called a very, very, very long name A and a very, very, very long name B, they will be the same if they're more than 32 characters. Now there are three other variable types mentioned there. Global, what we call global variables, two types, VRs and table, and the IEC PLC language has its own variables. I only mention that because some people will be using the PLC at the same time as the basic. So there's our simple case of a variable that we've named. So we've got the x named, offset named. So these are just names you just create. Now in traditional BASIC, I can do that. I can just name the variables, and they become a variable as soon as you give them the name. It's not a very good way of programming these days, though, because normally in a programming language you would declare your variables first. You would actually say this variable exists before you try to use it. With the BASIC language as it was originally written in the 60s, you didn't have to do that. You just said, you know, Fido equals 3, and a thing called Fido exists. So we have two ways we can use this. We can use it in the old-fashioned way, because that's how our BASIC used to work for a long, long time. Or we can actually dimension the variables first with this dim command. So you basically make the variable exist with the dim command, and then you use it. So you can see there's two types there. There's an integer type and a float type. If all you do is name it without using the dimension, it's always a float. Okay. But having said that, if you put an integer value in it, yes, it will be an integer value. But essentially the variable is a float. But you can actually put different variable types with the dim command. Now these local variables, they can be used in multiple programs, but they don't know each other. So if I have a variable called length in my first program and another variable called length in two other programs, they are different variables. They might have the same name, but they exist differently. They're in separate programs and they have a separate identity. So you just have to be a little bit careful about naming when you're doing multitasking and multiple programs, that you don't get confused about what the length is in one program compared to the length in another one. The advice is that you try and keep all the names different. So, you know, if I do have a length here, I might call that length 2, this one length 1, for example. So you make sure they are actually existing with different names. But that is up to you as a programmer. The system won't force you to do that. We can actually force it to use the dim statement and use the more strict way of programming by this thing in a thing called the mcconfig. The mcconfig is a special file which has all the configuration information for the controller. And if you set compile mode to 1, it will force you to use the dim statement. It will throw up an error if you don't. And that can be quite useful because, for example, if I sort of not using that and I name two variables, one I say the variable called Fred or something, and then I make another variable and I call it Frad with an A instead of an E, by mistake, the system won't tell you made a mistake. But if you use the compile mode 1, it will, because you've not dimensioned Frad, so it would actually tell you there's an error. So it's a much better way of programming is to set that compile mode 1, and you get better error messages. It does mean you have to, you know, if you've got a lot of variables, you have to sit down and dimension them all. So it is an extra step you have to take in writing the program. That's the downside of it. You have more lines of code to put in. Now the global memory I mentioned is split into 2 bits. There's VR memory, which is simply syntaxed or written as VR brackets and a number. So we've got VR0 there up to VR4095 in some of the controllers. The biggest controller we do has 65,536 of these VRs, numbered between 0 and 65535. So you can simply write to them like that. I can say VR20 equals 3, and I can say print VR20, or speed equals VR20. I can use that within my program. Or if I prefer it, I can actually use a name here. So I could make a name for my VR. So if I set index equals 20, and then say VR index equals value, then I've made it more readable in terms of a program. They're non-volatile, so they're automatically stored in flash memory in all the controllers. The same variable in all programs. So in the first program, VR20 is the same as the VR20 in another program. So they're globally seen across the whole system. And you can see there's a little viewer you can bring up in Motion Perfect to see the values of them as well, on the right hand side there. Table is the other type of global memory. Again, these are seen through all programs. So table 100 is the same table 100 whether it's in the terminal, whether it's in a program, or if it's coming from an HMI. It's always the same one. The syntax is slightly different to VR's. You set a table when you're writing to them, you can put multiple values in. So table index there. If index was 100, the first value, value 1, goes into table 100, the second value into table 101, the third value into table 102, etc. It just fills up the table as a kind of an array. You can only read out one table value at a time though, so value n there equals table index n. You can't put multiple values back out of a table. There's some limitations on that, but table is used for a number of things. One would be recipe storage. Logging data can go into the table. We can log data into the table. Putting in cam profiles for shapes of curves can go into the table. So it has a lot of uses like that. Now one thing about it compared to the VR is it's volatile, so it's not saved automatically in the background, apart from on the 508 and the 664X. So these two controllers, the lowest, I think 190,000 table locations are automatically stored in the flash, and then everything above is volatile. But in all the other controllers, the lower spec controllers, turn the power off, the table disappears. There is a command called called flash table, which allows you to store pages of table if you want to. So you can store table, but you must do it in your program. You've got to write a program to store it. It's not automatic. And again, there's a nice viewer you can bring up in Motion Perfect to see your table values if you want. Now on the PLC language, IEC 61131-3, the variables in there are not the same as any of the other variables. It's a programming system of its own. So any variable declared inside the IEC 61131 PLC is only known inside that language. So if I name a variable VAR1 and then I try to use it in the basic, it's not going to know it. There's no cross-referencing at all. The only thing you can do is you can link your local variables in the IEC language across to either VRs or tables, and it's called binding in this particular case. You set up a binding to the VR. And in that case, within the PLC language, you actually have to declare what type of variable it is. So you've got integers, reals, booleans, all the other types. The VRs are always floating points, numbers, so there's a conversion done automatically for you. You don't have to think about that, it's just done for you in the background. And generally, the floating point numbers we use, if you declare your variable as an integer and then it's converted, taken to a floating point VR, it's still an integer. It will maintain very accurate integers up to about 54 bits or something like that, 53 bits. So in the real world, it can be thought of as an integer if you need it to be. And then the different memory sizes are mentioned here. So they all have the same table value size. So they've all got 512,000 tables, and the flash memory is all the same. So you can save the same number of table flash pages. The VR is different though. That's the main thing really. You've got different maximum VRs: 4096, 16536, 65536 across all of those. I'm not sure if that's a typo or whether it really is. It seems an odd number. I kind of remember having a discussion with our software engineer about that, and I think that might be the correct number. It's just strange that it's not a power of 2. But I could be wrong. It might be a typo. You'll find out if you try it.